in the plane, and we'd like to know some interesting information about them. So, for example, here we have 2 points in the plane, x1, y1, x2, y2. And if you recall, you move over in the x direction. This is our x-axis. Here's the y-axis. So our ordered pair consists of a left and right movement with the x and an up and down movement with the y. So we have 2 points in the plane here. One question we could ask is, how far apart are they? So if I were going to take a ruler and I'd like to measure, what is that distance? And similarly, after we do that, so our distance. So here's our distance. Well, there is a point that would sit on a line halfway in between these 2 points. Well, that's called the midpoint. Well, where is it? Where is that halfway point between these two? Well, we have 2 formulas to help us out. One is called the distance formula. And the distance formula is based on the Pythagorean theorem. And that is, if we have a right triangle, so here's my right triangle, and if this is side A and this is side B, then the Pythagorean theorem says that the sum of the squares of the 2 sides must equal to the hypotenuse squared. And so you see the distance formula comes about by using that particular fact. Hopefully you can see that here. Something squared plus something squared. Now, how do we use the formula? Well, notice I need the coordinates of the x's and I need the coordinates of the y's. We just fill them in. The minus is part of the formula. So let's scroll up a little bit. What are my points? My points are minus 6, minus 5. So here's the x, here's the y. Minus 4, minus 1. Again, my x and my y. Now you might say, well, which one of these is x1 and which one is x2? Well, the fact is that it does not matter. Just be consistent. So let's see. I picked minus 4 for my x2 and minus 6 for my x1. So I filled that in. Notice I put the minuses with the coordinates. The one in red here is part of the formula. And here are my y's. My y's are minus 5 and minus 1. All right, other than that, we just calculate away. So let's see, minus 4 minus a minus 6 is minus 4 plus 6. Minus 4 plus 6 is a positive 2. 2 squared is 4. Okay, that's good. Minus 1 minus a minus 5, minus 1 plus 5. Minus 1 plus 5 is a positive 4. 4 squared is the 16. And now 4 plus 16 is 20. So this is the square root of 20. Now, if we were building something, we'd get out our calculator and we'd calculate what is the square root of 20, because we would need a decimal number. In our case, here in our problem, it says find the exact distance. And so what that means is if you have a radical, we need to simplify it. So square root of 20 is 4 times 5. I split it that way because I know the square root of 4. Square root of 4 is 2, and so the distance is 2 square root of 5. My midpoint is simply the average. Remember, my midpoint is the point that's halfway in between. So I've got my 2 points here. My midpoint is the point that's halfway in the middle. And so in some ways you can see that from the formula. It's just the average of your coordinates. It's averaging out how far in between the x and how far in between the y. Alright, so I simply plug in my x's, plug in my y's. The plus is part of the formula. Minus 4 plus a minus 6 is a minus 10. Minus 10 over 2 is minus 5. Minus 1 plus minus 5 is minus 6. Minus 6 over 2 is minus 3. So these are the coordinates of the point that's halfway in the middle. In question 2, we would like to know if these points actually satisfy this equation. So let's see if it does or it doesn't. Let's make it a little brighter so we can actually see it here. Okay, so there it is. There's my equation. So I have 1/9 and 7/28 over 81. Plug in the 1/9 for x, the other ugly number in for y. And the question is, if we add them up, do we get 9? Well, let's see, 1/9 squared is 1 over 81 plus 7/28, so that's a 7/29 over 81. And is that, when you divide it out, is it equal to 9? Well, yes it is. What about the other point? Minus 4 minus 7. Let's see. Minus 4 squared is 16. Plus a negative 7 is subtract 7. 16 minus 7 is 9. And yes, 9 is equal to 9. So that is a true statement. And finally here, the last one, we have the point 4 minus 4. 4 squared is 16. 16 minus 4 is 12. And does 12 equal to 9? No. That's not true. So the first 2 points do satisfy that equation, so they would live on its graph. Whereas this point, it does not satisfy it, therefore it's not actually on the graph.